Okay, hopefully we are live on YouTube as well. And I have to turn on the Zoom recording as well, just in case.
Recording in progress.
All right, so I guess we're good to go. So I'm really happy to see you sharing your progress on the Discord, and it really helps a lot to us as tutors to track your progress, to understand your difficulties and the challenges you're facing, and be helpful and to give you as much content as we can, as much knowledge as we can during this super intense workshop. Today, our goal is to explore machine learning possibilities using browser technologies, and we're going to make a few projects, and we're going to dive into a few libraries. And the first thing I wanted to show you all is based on a short conversation we had on our Discord about compressing the textures for your assets. This was not covered yesterday. I just told you that it's better to use WebP format for your textures. There is a tool called Squoosh, and there is a link on the Discord for this web app. Basically, all you want to do is get a texture. For example, this one is from Midjourney, and the standard size 1024 by 1024. If you drag and drop this, you will see this panel on the right, and there is an inscription saying compress. You can choose various file formats. What you're looking for is a WebP format, and you will see on the left your initial file size, like 152 megabytes, and on the right the compressed file size about 42 kilobytes. That's like 97% less, but you are saving the size of your texture. It's still 1024 by 1024. It's just another file format, and that's why it's so less in file size. And the blue button here is to download the compressed texture, and then you can use it in Blender to texture your assets. In the latest versions of Blender, there is a checkbox. When you export your asset, you can mark this checkbox to use WebP textures, but I'm not sure if Blender is transforming your JPEG images, for example, into WebP images correctly and so on. So I prefer just use WebP textures straight on. This may save you a lot of file size and a lot of difficulties when you're dealing with the 3D models in your browser. Okay, so that was like a brief introduction on texturing and modeling again. So today, the first thing I'd like to remind you that if I'm going to be talking for 2 hours today, maybe a bit less, but at any moment of my talking, if you think you have enough of me talking in your life, I remind you that you can just switch the sound of me talking off and follow the text steps that we have for every tutorial we're covering. And to make our meeting today a bit more fun, I'd like to suggest you a quick flash mob here in the Zoom chat or on our Discord channel. Just share one book that you've read recently and you'd love to share with others. I can start. Recently, I was reading a book by Hideo Kojima. Um, this book is called The Creative Gene. And if you know Hideo Kojima, he's a famous game designer. And this book covers different movies, different books, and different music groups and bands that somehow influenced his artistic work, his life, and he's just depicting various life stories and various scenes from and stories from books connected together. So I think for me it was pretty interesting, and I guess if you find this book, you'll be also amazed and find something interesting for yourself. So if you want to, please share your books. Otherwise, I will continue with tutorials today. The first thing we're gonna cover is not a tutorial, actually, it's a challenge. If you go to Challenges tab in Kodiia, you will see the Sorting Hat AI challenge. You can just press start, or as I was mentioning before, you can create a new project. Just make sure that you're using the Brain.js template for your new project. Hit create, and we'll create a new project. And here in challenges section on the right, you'll be able to get all the info for this sorting hat challenge also. The reason for using template is that it already has Brain.js library installed in your index.html file. Eloquent JavaScript. Yep, I know this book. Okay, there is also another one about writing the clean code, which is also super helpful. And it's not the book that you will read and then put back on the shelf. It's a book that will stay with you on your desk, and you will reread some parts of it from time to time. Okay, so with this challenge, Sorting Hat AI, and with this project, we're going to try to understand how to train neural networks, how it works, and what kind of information you need, or what kind of actions you have to make to train your neural network. So we have to open our script.js file. You can open an introduction step, and Sorting Hat is basically a hat from stories about Harry Potter. There is a hat in the Hogwarts school that will sort students into different houses, like there are 4 houses, if I'm not mistaken. So we're trying to recreate this sorting algorithm, but using our own neural network. The first thing we need to do is to define the training data. Okay, another book. Super. I'll check it after the tutorial. The first thing we need to do is to define the training data, because we have to train our network and we need some data to train it. Here we create an array, and if you remember from yesterday's session, an array is like a giant box for boxes, for different kind of boxes with various stuff. Here in our array we have 4 objects. Objects in JavaScript are a way to store information in a format where you have key and description. So for example, here we have input key and output key, and with our input key we also have another object that contains 4 characteristics of a student, for example, bravery, intelligence, loyalty, and cunning. And the output key contains another object saying the name of the house in Hogwarts and a value. So values here are between 0 and 1, and it's always better to use values between 0 and 1 when you're dealing with training your neural networks, especially using Brain.js library like we do here. So basically what we see, if the student is brave, his bravery characteristic is 1, then he's going to be in Gryffindor. If the student is intelligent, then he's going to be in Ravenclaw. If his or her loyalty score is really higher than any other characteristic, then he or she is going to Hufflepuff, and all the cunning guys are going to Slytherin. It's just a simple way to represent how this structure may work to sort students later. So now we have our training data. The next step we are doing is creating our neural network. We can just copy paste this one line of code. So what we are doing here is creating a variable called net, and we are saying that this variable is a new neural network class from Brain.js library. That's all. So we just say that our neural network is going to be named net. Then we have to train our neural network. Another line of code. We just say net.train, and in braces we mention the training data it should take to train on. Okay, another book in our collection. Super. So we say net.train and mention the training data we use to train the neural network. The next thing we can do, so now we have training data, now we have our neural network, we trained it. And there is also another book on YouTube. Thank you for sharing. Cool. I think we can create a list of the recommendations and the books you guys recommend, and share it somehow after the workshop. Like combine all the books in a single place, and you'll have your reading list for the rest of the summer. So we trained the network, and now we can check how it works. We just create a new object named student, for example, with different characteristics. It has like bravery, 08 intelligence, 06 loyalty, 04 cunning, 02, and to get the prediction result from neural network, we just run net.run command and mention the new data and pass the new data to the neural network. And then we console.log the result. What is console.log? When you're working with various programming languages, I guess, not only JavaScript, Python as well, you may be working with console. Is basically just a text-based interface to show the results of your program. And here in our code editor we have a console button. If you're opening the script.js file, you can see a console button, and it will open a small panel at the bottom of this section of the page. And comments like console.log will output the result of this command in this panel. So if I hit run right now, all the commands will run, and my new neural network will be created, it will be trained, and then it will be given a new student characteristics, and the result will be shown in the console. So what we see in the console is the probability of which house the student will belong to. You just have to look at the top scores. The probabilities here are between 0 and 1, and we see that Gryffindor, for example, is like 44, so about 45% that the student will go to Gryffindor. Ravenclaw, about 40%. Why so? Because we have bravery 0.8 and intelligence 0.6. They are pretty close, so the prediction results are also pretty close. Then we have loyalty 0.4, and we have like 1% chance that this person is going to Hufflepuff, and Slytherin like 0% almost, because his cunningness is really low. If you change data here, for example, let's make intelligence 0.96, then we will have like the highest probability that the student is going to Ravenclaw, 22%, comparing to like 2%, 13%, and 1% to Slytherin. So Ravenclaw wins, which is logical stuff here, I guess. Seems logic to me. Okay, so basically this is a quick algorithm on how neural networks train. And what you need to understand from here is that you have to provide training data, you have to get a neural network algorithm to train it on this training data, and then somehow use it. There are a lot of different neural networks algorithms. The one we are using here is just a simple neural network. There is no special name to it. In Brain.js, you can use different types of neural networks, for example, recurrent neural networks or long short-term memory neural networks. Those are different algorithms, and they give you different possibilities for different tasks. If you go to Brain.js, okay, this is not mentioned here. But if you go to home, Brain.js, and open it in Sandbox, you'll be given the link to Brain.js library, docs, and here you can find various examples and various types of neural networks you can use. So some types of neural networks are good for number prediction, for example. Some types of neural networks are great for stories generation. There are different tasks and different architectures and types of neural networks. But training neural network is an expensive process. It requires hardware, it requires some electricity, time, and so on. Right now in our project, this network is trained using the resources of your computer, which is...
Excuse me, are you from France? I just think you look...
which is fine for certain type of tasks. But depending on your hardware, you may experience, and depending on the amount of training data you pass to a neural network, you may experience different lags and you may need different time to train the network. So our next project we're going to make, our next tutorial is, I don't know, maybe I should stay in this project. I will just close this challenge and I will go to tutorials, and here you can see Transformers.js intro tutorial. This is the next project we're gonna cover. Yeah, we have importing library thing here, so I guess it should work out. We can leave Brain.js here as well. So Brain.js was for creating your own neural networks, just for you to understand how you can create it and train a simple one. Transformers.js is a library for JavaScript developed by a company named Hugging Face. Hugging Face, there is a link in introduction, step to Transformers.js library, and basically you can go to Hugging Face website from here as well. So Hugging Face is a company that tries to build and create open source solutions for AI. You can use various models like Llama models, the latest models from available for open source community. And initially, they created a Python library named Transformers, but not so long ago, I guess a couple of years ago, one guy decided to port this library to JavaScript to make to make a lot of different models available for a browser, for using in a browser. And if you go to the website, you may like scroll down and see different kind of tasks these models are used for. For example, natural language processing, various tasks like text generation, text classification, question answering, and so on and so on. Even translation and various tasks. There are also models for computer vision, for example, like image classification. So you upload an image and the model tells you it's a dog or a cat or something else. There are various tasks connected with vision, and there are also models for audio-related tasks, like text-to-speech, for example, or audio classification, and so on. And some models here are for multimodal tasks like document question answering. For example, you upload a PDF and then you type in some questions regarding the data in the PDF document, and the model will produce an answer, will return an answer to you. Let's try create a question answering, for example, pipeline using this library. Okay, so the first thing we need to do is to import the library. And for Brain.js, we were importing into HTML file. For Transformers.js, we import this directly into our script.js file. And if you remember, 3.js, we imported a different way yesterday. Part of the 3.js was imported in HTML, and then we also used import statements in our script.js files. Here we just straight ahead use import statements in our script.js files. So we have to mention the download link for the library, and here we use 2.6.0 version. If I'm not mistaken, the latest version of the library is 2.17.2, something like that. But we'll check if this one works. It's fine. Okay, so we import two elements from the library. The first one is called pipeline, and the second one is called env. We need to use and import this env thing because we need to disable search for local models. Because the library is working in a way that it will search for local models on your computer first, and if we won't find anything, it will not work. So we have to disable this function, and then it will search for the models we need online. The third step here is loading a model. So how do I know what kind of model should I load? If you look closely at the code provided, what we do here, we create a variable called answer, just a thing giving an answer. We call it answer. Nothing super complex here. Then we use this pipeline tool that we imported from the library. And in the braces, after the pipeline word, we just mention type of the task we're trying to solve, like question answering, and what kind of model we want to use. And you can see another word here, the word await. This means that the request with this pipeline tool is going to take some time. And when your code is written line by line and the computer is implementing your code line by line, some parts of the code may take longer time to produce the result. And if there are parts like this in your code, then you need an asynchronous methodics to use, and that's why we're using this await word here. Okay, I hope it's clear. If it's not clear, just ask a question. I'll try to understand to explain it more. But we will use more await expressions today later, and I hope you'll get used to it as well. So how do I know what kind of models should I use? If you go to the web page, question answering, you can see a models link here. So if you click on the models, you'll be provided with various types of models you can use. And basically you just copy paste this name of the model into your code to use it. That's it. Some models work better, some models work better in certain situations, some models work better in other situations. So before choosing your model, make sure you follow the link with the model name, you read the description. If nothing is here in the description, you just go to the basic model, which is designed for using the Python library, and read the description for this model. In order for language models to work in or other kind of models to work in the browser, they are changed to different kind of formats. For example, this model is using a technology, if I'm not mistaken, that is called ONNX, and this is like, I'd say you may think of it like a file format. For example, you have different kind of file formats. One is JPEG, another one is WebP, and so on. And some of them work great on your desktop devices, like JPEGs, for example, but they won't work in the browser because you have to use another file format like WebP, for example, just to get the smaller weight of your file size, or smaller file size. So I guess ONNX here is doing the same thing. They're just converting a more traditional model into a model that is usable in a browser. Okay, so this is why and when we can select some kind of models. Next step is setting up the context. The model we're using is for question answering, so you have to provide the context. So you have to like grab some amount of data and tell the model, this is the data and this is my question, and it will find the answer to your question in the data you have provided. This model we are using here is trained to understand small amount of data. I guess you can just print a novel here. The model will just grab the first, I don't know, if I'm not mistaken, 500 words or something like that, Usually the models are measuring everything in tokens, so I guess you may think of every word as like 1.5 token, for example, depending on the length of the word, depending on depending on the length of the word, it is converted into different kind of different amount of tokens. So simple word may be 1 token, and and the longer word may be converted into 2 and 3 tokens, and so on. So basically, I guess the middle value here is like 1.5 token for word, and if this model takes about 500 tokens, then you can have about like, 300 words, for example, in your context to provide it to the model for question answering. So now we have model, now we have context, and the next step is to ask some questions. Okay, so just copy paste. And again, here we have a variable named result, and this variable awaits for the answerer with these parameters, a question and a context. So the context here is that in this tutorial we're going to explore neural networks to start students into different Hogwarts houses based on their attributes. And then we ask the question, what could I do? Let's see, let's hit run and see what its model does. And the answer is provided as an object as well, and this object has 2 parameters. The first parameter is answer, and the model returns like a fragment from the text, which will be the answer to a question, like using a JavaScript library called Brain.js to create a train the neural network. So this model here is not rephrasing the answer in a more human-like way. It just returns the fragment of the text that will be close enough to the answer on the question we provided. And the second parameter that we have in our answer is called score, which means the I don't know, the higher the score, the more likely it is the answer to your question. The lower the score, the more likely it is not the correct answer, but it's the best the model could find in the text you have provided. So basically it works like this. And that's it. That's a simple thing, the simple algorithm for using Transformers.js. You just import the library, you turn off the local models, and then you create a thing specifically for the task you're using and the model you want to use, provide a context if necessary, and grab the result. That's it. Probably we can try and use a different model, a different task. For example, text generation. What kind of models we have here? For example, let's take GPT-2 model, and here is JavaScript code also you can use. So let's grab the model name. Now I can grab just this part of the code, like this. Get it here. So what we are doing here, now we are creating a variable called generator. We await for the pipeline using text generation task, and the model is GPT-2. For the model, we provide the beginning of our story, like once upon a time, and then we wait for the prediction. And let's run and see what happens. First we get our answering model, and sometimes you have to wait for the model to load, and after the model is loaded you'll get a response like an array with different objects, and in every object there is a parameter named generated text, and the generated text is the answer of the model. Once upon a time I was in a room with a woman who was very attractive. She was, and then this thing stops. This stops because you have to provide some kind of parameters like this example here, maximum amount of tokens for the model to produce. This means like how many words the model will predict. There are also some other parameters that you can specify here. I guess you can find all data in the docs if necessary. And when we were thinking about creating this workshop, we were thinking that we will use this library, Transformers.js, but it appeared that the models available here are not really suitable for our tasks. The most powerful model here, I guess, is Phi3 model presented by Microsoft in May, and still you cannot use this model just the way we are using models here. You have to create a complex workaround for this model to work and upload the beta version of this library, which is not available yet for everyone. So after playing around with a great amount of models available here, we found out that we could not build agents with the models provided here. But these models are great for some more simple tasks like question answering, I don't know, some generating simple stories like we're using the GPT model 2 here, and so on. So we switched to another library at the end. What is GPT, by the way? We were talking before about different kind of architectures of neural networks, and I was saying that there were recurrent neural networks, long short-term memory neural networks, and so on. GPT is short for Generative Pre-trained Transformer. If I'm not mistaken, in 2015, the transformer architecture was presented and made publicly available, and this is when all the modern AI hype begins, because transformer models appeared to be way better than all other neural networks used before for text generation, of course. And they appear to be really powerful and really great at solving different kind of tasks. Yeah. Okay, so this is final code for our project right now. Do you have any questions? Everything's super clear. Okay, then let's jump to another tutorial. Building AI multi-agent system. Okay, so Transformers.js, when they download the model also runs on your hardware using your GPU and graphics card. this is available due to the new web GPU technologies being developed right now. How we can check if there are syntax, you mean errors in our code? Is there a way for debugging? If you're looking for syntax errors, the editor itself will highlight something like if I just mistype result here, for example, you will see the suggestion here that the editor couldn't find the name result, and did you mean a result? And you can look at these things here. Then if you run your code with mistakes, for example, if I run it like result here, let's remove all this code and I hit run, then in my console I will see an error, uncode reference error, result is not defined. So you will see that you misspelled something. That's the way for debugging your code. If you have any errors, they will appear in console. There are also special developer tools in every browser, and you can access them by pressing Control-Shift-I on Windows machines, Command-Shift-I on macOS, and you will get a separate panel here. The panel is presenting the structure of the web page, like all the HTML code. The console window is opened in script.js file with the console button. Just press console button here and you will open this console tab. In the developer tools, you will see the HTML structure of the page. You will also have a console tab here, and you will see all the mistakes that are happening with your code. But these are mistakes that can be triggered not by your code, but the library itself. Sometimes the library, while producing great results, still creates some mistakes. So even if you see mistake here, this doesn't mean exactly that your code will not work. Maybe just fine. And there are also various kind of messages different models are producing. So while downloading, for example, the model, and while running the model outputs some kind of these messages, and it doesn't prevent it from working. It's still okay. It's just something connected with how the library was developed. And since these technologies are experimental and invented right now, there are a lot of different kind of errors appearing here. Yeah, is there a question? Nope, all good. So you can also check for errors in this console tab here. There are also different tabs like network, for example, which records various resources. And for example, if you are downloading a model, let's try and hit run, you will see some network messages here that you are downloading a Transformers.js library first with this version and the amount of data you have downloaded, and then this model, this library will download the model you have specified. The model is using WASM file. WASM is short for WebAssembly, another programming language used for complex mathematics running in the web. And you also can see where this model is coming from, and so on and so on, different stuff, and the size of the model itself. So right here we are using like 2.6 megabytes of data, which is quite small, and the model is not that big itself. So, okay, let's go further. After we thought that we could not make our agent system with Transformers.js library, we switched to WebLLM library. WebLLM is a library that allows you to use more powerful models like Llama 3 models and Phi 3 models on your device. What this library is doing is downloading the models on your device and then use your hardware to run the models and make text prediction, for example, and you can ask the model to write some code and so on. So we were thinking that we will make everything works with this library. But then the models we need are rather powerful and they require a lot of data. So Phi3 model, for example, which is counted to be a small language model. There are large language models like LLMs and small language models. So Phi3 is counted to be a small language model. And it takes about 2 gigabytes to download the model, and then it requires some also rather powerful hardware to run the model. And waiting for 2 gigabytes to load in your browser while you're on a Zoom and streaming it all in YouTube is not a great idea. And Phi3 is a really small model, so 2 gigabytes is a really small model. Llama 3, for example, with 8 billion parameters is about 8 gigabytes. So I will explain later why do we need these models in about 5 minutes, I guess. Llama 3 with 8 billion parameters is about 8 gigabytes, and this model is even bigger and requires even more hardware, despite the fact that it can run really in your browser. If you want to use those models locally, first of all, you can use this tool like Chat with WebLLM, for example, or there are different kind of projects appearing allowing you to use kind of models like this. One of them, if I'm not mistaken, yeah, it's called Chatty UI. You can use it as a ChatGPT analog, for example, but you can select different kind of models here. They are all open source. Those are models produced by Mistral company, Qwen company, Llama, and so on and so on and so on. But they will all run locally on your hardware, and they are pretty capable of the tasks we need from them. So let's go back to our final project for today, building multi-agent system. Okay, so what we will build, we will create our final project as we were showing it to you yesterday. We will create an agentic system. We will talk about prompt engineering and using those AI models for our tasks. And we will develop a new HTML interface and 3D scene with Three.js, uploading your custom models that you are designing using Blender. First thing first, what do we need to do here? No script.js is necessary. Let's add Three.js library to our HTML. Okay, I hope this is the right place in my HTML file for this model. And then some HTML elements to create a user interface. So basically what we want to create is a small input field with a generate button that will take your prompt and what kind of city you want to create, and then it will trigger the agentic functions for them to generate a description of your city, provide a functional balance, and based on this functional balance, provide allocation of various elements in space to be used for visualizing your city with 3JS library. Okay, so this is the basic interface. What we have here, we have several div elements that help us group other elements like input fields, for example. Input fields are used for some input like passwords, emails, telephone numbers, just text inputs, and so on. Buttons are used to create button, and we have IDs for our input elements and button elements for us to be able to use them later in our JavaScript file. So the button has text generate on it. And yesterday we were mentioning that there are HTML tags that are paired and unpaired. So you can see that button is a paired tag, so it has button opening tag and button closing tag with a slash, and input is unpaired tag. You don't need a second input tag to use it properly. And this is basically all we need for our input area, just an input field and a button. The second part of the interface is where we show some information provided by the models we're going to use. So this is another like div, just a container for engines answers, and it provides few headings like city description and functional balance and empty paragraphs for now, because these paragraphs will be filled later with JavaScript. And of course, we have a canvas element here to draw our 3D graphics on the screen. So if you run the code now, you will see that we have two headings, input field and generate button. That's it. And hopefully we are using the 3JS library correctly, but we'll check this later. Okay, the second part for this thing is CSS setup. So these are some styles we can use, and with the styles provided, we can maybe have a background here as well. Yep, this way it's more clear. So the styles basically help us change the outlook of our input area and the button itself, and set up some fonts we can use, create those fancy shadows from the menu panel here. And all right, well, I guess we'll come back later to this. Let's dive into the JavaScript file. So first of all, we have to import 3JS library, and we're going to use some extra add-ons here for the library for interactivity and for loading custom models, the GLB models from the Blender that we were creating. And then we are creating the agents here. So how this agent thing works. First of all, we create 3 agents. It's up to you how many agents you want to create, and if you were reading our blog post that we were sharing before the workshop, this is the blog post we were sharing about multi-agent AI systems. And here we discuss different companies and different tools providing and creating multi-agent AI systems. For example, Kodiia AI is a company that provides a framework for creating multi-AI agent systems. Okay, so you can like read a bit more on what they are doing here, but basically what they're suggesting is that every agent you're trying to create is like a person. You have like a team of various professionals, and every agent is a professional in a specific field. For example, one is an architect, another one is a don't know, architects take too much different fields to be professionals. The first one is developing a master plan. The second one is developing functional zones. The third one is providing massing models for the master plan, and so on and so on. So you kind of split your giant task you want from the agent system into small parts and make every agent responsible for his small part. And this approach works better than just prompting large language models with a single prompt, like create me a city. Imagine you're an architect and create me a city. First of all, this is a really complex topic, and the model itself may not produce the good enough results. So that's why these agentic systems are developing right now, because they let you split your complex task into simple tasks, more small tasks, and then large language model will understand those small tasks better and produce better results. And mostly this idea is implemented now in software development. So there are a lot of pipelines and frameworks for creating software with agents. For example, this AutoDev tool from Microsoft, they have various agents for like file editing, testing, implementing different kind of tools, and so on. There is also a Maestro thing that represents three agents. One is for breaking down tasks into smaller parts, and two are executing those small tasks and controlling the quality of the execution. Another approach is called mixture of agents, presented by a company named Together AI. This is a different solution. They kind of you provide the request, a prompt, for example, to a model. They use a number of different models providing an answer to this prompt. Then on the second layer, they choose the better version, the best version of the answer, maybe update it a little bit, and so on and so on. It's like a loop. And then in the end, you get the polished answer, which is way better than just an answer provided by a single language model. There are also tools like GPT Pilot. Well, if you were reading this article, you must be familiar with what's happening with this agentic system and how they work. But basically, they let you split a complex task into smaller tasks and prompt the large language model to address this small task and produce better result as an outcome. What we are going to do here is we are going to have an input where we will describe what kind of city we want. A high-rise city, for example, a small city, a slab city, and so on and so on. And then for the sake of this workshop, we came up with three agents. The first one is providing a city description, so it will generate a more detailed description of the city based on the prompt you provided. So it will come up with ideas like what kind of feature this city have, any kind of special I don't know, special structures, and so on and so on. You'll just read what this model produces, I guess. And the second agent will be given this city description, the detailed city description, and will output a functional balance based on the city description. So how many residential parts in this city, how many commercial parts in this city, how many natural parts, or I don't know, blocks for the nature in this city, and so on. And finally, the third agent will produce code that we can use in our Three.js library to visualize this kind of city that those agents came up with based on the prompt you provided. So this is high-level overview of what we are doing here. Is that clear, or do I need to talk a bit more about this? Okay, no questions. If you have any, feel free to ask. So every agent is a separate function, and we call functions like get city description agent response, get functional balance agent response, get voxel data agent response, and so on. So I hope the name of the functions are self-explaining enough. You can come up with a different agentic pipeline. For example, maybe you will decide that to design a city, you have to use different kind of agents, and they should do different tasks, for example. And it's fine, you'll be able to come up with your own functions and prompt your own language and produce a different result. This pipeline is super experimental right now, so there is no like single answer how we should build multi-agent AI systems, especially those systems, how we should build them for architectural tasks. So it's all very, very experimental, and it's up to you basically to experiment with this thing. So in every function, we have a special way to create our prompt. Basically, when you're working with large language models, you just have an interface like here, an input, and you just type your request and it will produce a result. But when you're creating tools like this, you have to provide prompts in a various way. So here, first thing we do is create an array called messages, and this array contains two objects. The first object contains a system prompt. So this prompt is responsible for what this agent is and what it has to do. So in this system prompt, for example, for agent creating a description of our city, we provide a prompt like you're an expert architect, you're designing a voxel grid-based city structure, and your goal is to provide 3 sentences describing the city solution based on the provided query. Here is the query. And the second object has a role named user, and it contains just an input from the user. So the system part of the prompt explains what this thing should do, how it should behave, what kind of solution it has to provide, and then you give the query. In order for you to be able to use powerful enough model for this task, we created a special API available via this link here, and I hope this will be enough for our workshop. So basically, the second part of every function is getting a message from a model. And we use here again asynchronous behavior, like we use fetch function. Fetch is for providing a request to a server located somewhere far away from you, and then getting the answer from the server back to your front-end application here. But basically, you just don't need to understand how this works for the sake of this workshop. Just make sure that you keep this part of your code untouched. All you have to change basically is this prompt here, like system prompt, if you want to get a different behavior from the agent. This fetching part should remain the same. So when you are sending the prompt to this link provided here, you will use Llama 3 model with 8 billion parameters, but it will run far away on a server, and you will get a message back from the server, and it will work pretty fast, I guess. Defining different zones based on function. Can you rephrase the question a bit? Different zones of the city are based on the functional balance, I guess. So first we kind of create a detailed description, then we provide a functional balance for zones we want to use in our city, and then we visualize all this stuff using Three.js. The logic is like this, basically. So what you get from the server is a message in a special format. The format is called JSON. It's very popular file format for especially web apps. And in order to be able to use this message in our code, we have to transform this JSON format into another format. So basically we use this await message.json command here, and we say that the city description is this transformed message in JSON format. Then we console log city description in our console, and we will also see it in our interface. And this function with the description agent returns this kind of description. The second function is the functional balance agent. This works the same way as before. It just has another system prompt, like you're an expert architect, you're designing a voxel grid-based city structure. Okay, each voxel is a building, which is not true already, a nature space or an empty area. You're giving a city description. Your goal is to provide a functional zones balance for the city, provide options for functional balance, provide answer as a JavaScript object like this. And here you kind of describe what kind of result you want to get from an agent. You want to get an object with 3 parameters: residential area, commercial area, and nature area. Start your answer with the how do you call this sign? Curly bracket. Yeah, and here is the city description. So the system prompt gives a model an understanding that it should provide a JavaScript object in return based on the city description it receives. And then the user role is again just providing a description that we get from our first agent. Then we send this request to our API and get the message back. Then in the message we receive, we will get a lot of data apart from the JavaScript object we requested in our prompt. We will get an object first, but then we will get also a lot of other stuff. You can basically, I guess you can console.log message object here as well, just to see what the model will return. And you have to retrieve just an object from an answer. That's why we are using these 3 lines of code here. So we are first searching for the first curly brackets, and then we're searching for the second curly bracket. Then we extract everything in between those brackets, and this is how we get our functional balance. The third agent, Voxel data, is provided with different kind of prompt. Basically, it can be fixed a bit, but the idea is the same. You're an expert architect, you're designing a voxel grid-based city structure, you're giving a functional balance. Here is the balance. Come up with an array of objects in JSON format where each object is structured like this. And here we provide the way we want to receive the answer from the model. For example, we want to understand what type of an object it is, a residential, a commercial, or a nature area, and the coordinates of an object. And coordinates represent numbers from 0 to 5, but you can fix it all. And we also ask for just 20 objects. Experimenting with various amount of objects, you can create a more sophisticated city or a smaller one and so on, but the larger amount of objects you have, the harder it is for LLM to provide them. So basically 20 worked always fine for us, and we tried 30 and sometimes it just did not return enough result, or maybe some other problems are here. But well, basically if you're looking for 20 objects, you should be good to go and everything should work fine, but you're free to experiment with all this stuff. Then we are sending the request to our API, we get the response back. We search for array borders, the square brackets, the first one and the second one. We extract all the data between those square bracket, and this is how we get our city voxel data array. We also ask it for a JSON format as an answer, and we have to parse this format in order to retrieve a array format that we can use in our next part of the code. Okay, these are the agents. The next step is our interface interaction. So basically what we do here is retrieve the button from the HTML document using the ID. We generate event listener for the button. In order for you to be able to click a button and execute some action, you have to add event listener to the button. What kind of event are we looking for? We're looking for a click event. So basically when we click on the button, use execute those actions like get input value, what kind of prompt you provided here, console log just for us to be able to see that the prompt is received, and use this function then start agents chain of thoughts. This is a special function that combines all the agents and describes the logic how they should work together, and this function is written here below. We'll get to it a bit in a moment. So description text is the empty paragraph we were creating a HTML to describe and to show the description provided by the model. Balance text is a paragraph to show the functional balance provided by the model, and this function start agents chain of thoughts. It takes an input that you provide in the input field here, and then it triggers a succession of agentic workflow. First, we need to generate a city description using our city description agent function. Then we get the description as a result, display it in our interface, and use it as a prompt for our functional balance agent. Then we receive the result from the functional balance agent, update our interface, and use this as a prompt for our voxel data agent. And after we get the array with voxels and different kind of elements we want to use in our city, we trigger the generate city function, which is a function from the next part of our code. Okay. The next part is gonna be, I guess, more simple. At least you should be familiar with it. It's about creating your 3D scene using Three.js. So the same way we did it yesterday, we just create a scene first. We also just create a variable to describe the color of the background and the fog we want to use in our scene. So we use commands like scene.background equals new3 color, and instead of writing color here like we did yesterday, we just use this variable. And the command like scene.fog with the same color helps us to create a fog in our scene. Camera setups, just as yesterday. Canvas, the same thing we did yesterday, just retrieving this canvas element using its ID in our HTML here in JavaScript. Setting up the renderer tool to render our scene using the canvas element provided in our HTML file, and using this anti-aliasing option for more pixel perfect results. Setting the size of the render, pixel ratio, resize function for us to be able to change the size of our window and update the picture here. Adding this function to our window using add event listener command, as well adding some lights, sun for directional light, setting up sun position, and some ambient lighting as well. Okay, the next part is visualizing the city. What we do here, first of all, we import a special tool named GLTF loader. We already imported in the beginning of our code, but here we're starting to use it. We say that our new variable loader is this tool, GLTF loader. And then we describe our function generate city. This function receives an array of data and then goes through the array, looking at every element, and those elements have parameters like type. And if this type is residential, then we load a special model which is for residential areas. If this parameter is commercial, then we load a model for commercial areas. If this parameter is nature, then we load a model for nature areas. Those links for the models are available for you when you upload your assets in your project. So, for example, if you upload an asset here, for example, let me upload an asset. Okay, this is my asset. I will upload it. And when I click on my asset, I get this link. I can click copy URL. I can go to my script.js file. It's not saved. All right. I forgot to save my project, so everything is gone. All right. But basically, you got the idea. You just have to replace the link with your link. So we were here, our generate city function. For every unit that we are creating, we also set up some special rotation just to rotate them randomly so that the final outcome was not so repetitive. And we have to provide a position for each unit, which comes from the numbers provided by the model, x, y, and z coordinates. And don't forget to add this to your scene using scene.add command. So this is called conditional statement. It is used in every programming language. And basically you have to say if something, then do something. If something, then do something, and so on. So here we check for types of the areas we want to create, and then load necessary models in necessary positions. That's it. Then we set up some interactivity using orbit controls. Orbit controls is a thing from Three.js that allows you to rotate your scene, zoom in, zoom out, and so on. There are different types of controls available in Three.js, and finally we run our animate function just the same way we did yesterday. Request animation, render, and special command we use here is update controls to update our orbit controls for us to be able to really rotate and zoom in, zoom out in our scene. Okay, so let me check final HTML code here in my HTML file. Okay, and some CSS as well. And hit run. All right, so now we have our working scene, and we need to provide a description. I'm always providing some high-rise city, and click generate, and you will get a city description from the API. You will get functional models, functional balance from the second agent. And if you go to console, you'll be able to see various data provided here. So you will see the description, you will see the functional balance as well, and you will see an array with objects describing the position and types of various various elements: residential, commercial, and nature. Okay, let me try it once again. Okay, and here we see our city. The fog is controlled with this scene.fog command here. So there are two types of fog in Three.js. One is a simple fog, like we use here. You just set up how close to the camera it starts and how far from the camera it is completely foggy. So 5 meters, for example, from the camera, you will not see anything, though this fog is pretty dense, and you can play around with those setups. Then orbit controls is this thing that allows you to rotate your scene and fly around. And basically in the models we were using, the nature areas are marked with this pink mushrooms. But you're free to create your own nature areas as you see them. And other assets are residential and commercial stuff. Okay, thanks for your comments. You're so silent today. I'm so scared because I feel like I'm talking too technical stuff and you're not getting any pleasure with this workshop and so on. How does model know which parts of the models are nature? The models don't know. The models we use just provide a description that there should be like this percent of nature parts, this percent of commercial parts, and this percent of residential part. The third agent, giving this functional balance, comes up with the array of objects saying like type residential, for example, and the coordinates of this object. And it will basically understand that it needs to provide 20 objects. For example, almost 10 of them should be residential. So this agent will provide 10 residential objects with different coordinates. Then it will provide other 10 objects for commercial and nature. The model doesn't know what these objects look like, so it just provides a description and really technical description, and then we provide our assets to visualize this. So the model doesn't know that the nature part is visualized with mushrooms in our scene, and if it would know, I don't know, probably it would not provide us any data at all. Is that clear? Did I answer your question? All right, thanks. So basically this is it. So in our project here, we combine the agentic stuff, creating different agents that are supposed to complete different tasks, and they are kind of depend on each other in a linear way. So one agent produces a result, another agent is given this result to produce its own result, and so on and so on. It's like a chain of agents. In other agentic systems, there are other agents that, for example, can provide a feedback. So you can implement an agent that will get a city description, review it, and provide some comments. And then using these comments, you can trigger again the city description agent, saying it to provide a different city description using these comments from the reviewer agent, for example. So the pipeline could be really complex. And the more you generate using models with agents and so on, the more time it takes for agents to produce a result, review it, for example, update it, and so on and so on. So agentic pipelines really take some time to produce a result. But here in our case, for the sake of this workshop, we're using, I guess, a relatively simple pipeline allowing for quick responses from the agents. How can I change a voxel unit? The voxel units are all mentioned in this generate city function. These are the links mentioned here. When you upload your asset, you can use the link for your own asset. So basically just change this line of code and this code will upload your asset and so on. If you want to create more parts for your city, not, for example, residential or commercial or nature, maybe you imagine a different kind of city that doesn't have these parts, you're free to experiment with prompts and with models and so on. I remind you that for generating models, we created this simple tool, and it's now added to a template here. You can just open Sandbox, for example, hit run, and you will be given this 3D modeling thing here. Some details about how it works are explained here, that it is a cellular automata and you can export an OBJ file using this. Then use it file in Blender, upload some textures, implement some textures, and export it as a GLB asset and upload this GLB asset to your project to use it in your scene. how can we forward this tutorial in our account, as there is no save button for me. You go to your home page in Kodiia, to this page. You need to log in using your email and password. Then you have this green create button available for you. Just select a template, a static one will do. Hit create. You will create a new project. Here in resources panel, in tutorial section, you will see this tutorial that we are using today. And you'll be provided with all the code necessary: HTML code, CSS code, and JavaScript code. Just click copy and paste it to a necessary file, and everything should work. 3 different GLB objects. It's up to you. In our template, we use 3 different GLB objects, as we are creating 3 different functional zones using our agent system. You may still create, for example, 3 different functional zones, but use, for example, 2 residential assets, and then mixing them randomly in your scene. Or you can use a different amount of functional zones, so you can use a different amount of GLB objects. But if you want to stick to the template that we provide, yeah, basically you can just create 3 different GLB objects created by you, change these 3 links showing the way, the path to your models, and that's it. It should work. If you have any questions while working on your scene, feel free to reach us in Discord, and we will be happy to answer as quick as we can. Today's tutorial is so technical, and tomorrow you'll meet Alec, and he will provide you with more artistic, I guess, pipeline and workflow. He will explain you how to use ComfyUI and Midjourney to generate textures, to generate some artistic visions for your projects and your cities. That's it, I guess. So basically, this is the most complex part of our workshop today. Okay, yeah. Well, not so weird. It looks cool. Thank you for sharing. I remind you that you can share all your projects in our Discord channel as well, and we're super happy to see what you guys are doing. Yep. Again, we are now all in a strange period in our history when this AI hype is booming, and everybody is saying around that AI will replace you at your job and so on. And I guess that this workshop and you're working with agents, AI models, and so on will give you some time to think whether it's true or not, and who will replace who in the end. How to remove ping fog in your script.js file. Where is my project? Here is my project. In your script.js file, you have code responsible for your 3D scene. There is a variable named bg color. If you want to find it in your code, you can hit Ctrl F. You'll be provided with a search bar, search panel. You just type bg color, and you will find all the places where this variable is in your code. And the first one where you declare the variable, the line const bg color equals, and here is the color itself. So you can type a different color value, and it will change the background color and the fog color as well. If you want, you can experiment with different colors for background and for the fog color and see what happens. You can provide colors in different formats. In this one is using hex format. You can also just type color name like red, yellow, blue, or you can provide an RGB format like RGB and then brackets, round brackets, and 3 values from 0 to 255. So for example, a red color in RGB format will be 25500. Hit run. Okay, generate, bam, 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 and yeah, and here I have a red fog and red background for my city. With orbit controls, you can use right mouse button to pan the camera in your scene. Left mouse button is to rotate the camera. The wheel is to move closer and further away, and to zoom in and zoom out. Yeah, and you also, well, just experiment with mouse buttons and you'll understand how it works. Nothing so special here. Okay, do we have, how did you learn all this? Don't know. I just practice a lot. You just need to practice a lot. There are various courses, various resources available online for you to learn web development, for you to learn 3GS as a library, for example, for you to learn 3D modeling, and so on and so on. And you just start experimenting with different stuff and see what works for you, what doesn't work for you. For me, I was super passionate, I guess, about building this Kodiia platform, building a platform that everyone can use to create their projects. And it's still in the early stage, but it's working and so on. And this project made me move forward constantly. So I started learning about front-end development, back-end development, 3GS as a library, and so on and so on. And there are always things you can learn more and more and more and more and more. 3GS examples, fog, yes. Various types of fog you can use, yep. And in docs, if you type fog, you can see this fog and you can see fog exponential. And instead of the usual fog we are using, you can use this exponential thing. Here you have to provide the color of the fog, and this parameter is just the density. So in traditional fog we use the distance from the camera to set up the fog density, but here you just use one value to set it up. So you can experiment with this also. Okay. So I guess that's it for today, guys. If you want to share your project, a minor update I made. Look, in your projects tab, when you're logged into Kodiia account, there is a project tab here, and here all the projects you created, and you have an edit button to open this project and continue working on it. You have delete button to delete this project and never see it again, and you have share button that will let me Okay, press this. This share button will open this project in a new tab, and you can grab this link from here and just copy paste it to the Discord and to your friends, to your mom, and say, "Hello, mom, look what I made." Yep, that's it. So we are waiting for your projects on Sunday. Tomorrow is Saturday and you still have time to learn new stuff with Alec, but then Saturday night and Sunday morning, or it depends on where you are in the world, you have to work, 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 and see you all. Okay, need some break, guys. Take care. See you all online.
Recording stopped.
Okay, bye bye. See you all.